Welcome to this second lecture in our course block on multi-access solutions. In this lecture, we will look at some of the key concepts and challenges involved in realizing multi-access communication. My name is Anna Brunström, professor in computer science at Karlstad University. In this lecture, we will first shortly recap what multipath transport is and how it differs from single-path transport. We will then take a look at 4 core concepts involved when realizing multipath communication. First, path management, how you manage the different paths involved. The packet scheduling, how to distribute your traffic over the different available paths. If you have a reliable communication, how to realize this reliable transfer over the multiple paths. And finally, congestion control, how to manage the load of the data sent over the different paths. So let us first shortly recap what multipath communication is. So anytime we communicate, also over a single path, for instance over TCP, we are required to manage a number of things for our communication. We need to have a proper connection management. We have to set up our connections and we have to tear them down and finish them at the end. We also have a number of mechanisms related to the data transfer to ensure that we have reliability through various retransmission mechanisms and also to ensure that we don't overwhelm the network with our traffic using proper congestion control. So when we then communicate over multiple paths, we have to take care of the same aspects as we have in single path communication. We have to have a proper connection management and we have to have the features in place to handle the data transfers. But additionally, we now have to consider the fact that we have multiple paths available for our communication. So as seen in the figure, a typical multipath scenario is that the client has more than one interface available, and we are then able to communicate over both these interfaces in our communication to the server. So what are then the key things that we have to take care of? So in connection management, when we set up and tear down our communication, we have to take into account that we now have multiple paths, and we typically refer to this as path management. We have to decide how to set out our paths and how to decide which ones to use. In our data transfer, we also have a number of things to consider. So how do we send our data over the paths? Well, we now have multiple paths available, and we therefore need some form of scheduling mechanism that determines which path to use for sending a particular packet. If we have a reliable transfer, we also need to think about how we identify the data sent over the multipath connection and how that relates to identifying the data over the single paths used underneath. And how do we do the retransmissions in case some data is lost. And similarly, our congestion control now has to work not only over one path, but may have to consider how we communicate and manage congestion over multiple paths. And of course, we have a number of challenges related to these mechanisms. And one of the most important parts to consider when we communicate over multiple paths is path diversity. The more diverse our paths are, the more complicated it gets to use them in an efficient way, and the more important it is to use them effectively in both our path management and for our path scheduling. Fairness is also a dimension that now has additional things to think about, because now we have not only the fairness between flows communicating over a single path, but we have to think about how our possibly multiple paths behave fairly over the network. And of course, in this case, we may have multiple paths between the sender and the receiver, but they may not be disjoint throughout this whole communication. And finally, the deployment issues are also very important. If we want to extend, for instance, a protocol like TCP with multipath support, as is done in multipath TCP, a lot of design decisions and work in the protocol is due to the fact of making these extensions deployable. So how do we ensure that our traffic can still go through the network and through the different middle boxes that may be in place? So these are some of the things we need to think about. Let's now talk about each of the core mechanisms in a little bit more detail. So let us start with the path management. So as I said, the path management issues has to do with how to manage the different paths available for the communication. And here there are a number of key issues to consider. So the first issue here is which path do we open our communication over? We may have now multiple opportunities, multiple possibilities for how to connect to a server. So which of the paths do we use to initiate communication? This can have a large impact on our performance. If we now have multiple paths, we also have to decide, do we use all of them for the communication? It may not always be beneficial to use all the paths. So depending on the requirements of the application and the conditions of the different paths, we may want to use them for simultaneous transmission, or we may want to use one of the paths as a backup path. And we also have to think about the dynamic reconfiguration. How do we allow new paths to be added to the communication, and how do we then move traffic between the available paths? So the next aspect to consider is packet scheduling. So let us now assume that our path management has set up a number of different paths between the client and the server. The packet scheduler then has to decide which path to use to send a particular data segment over. And this decision can depend on the goals of our communication. So there are typically many different schedulers available that have different goals for what they try to achieve. Do we try to optimize the throughput? Do we try to optimize the latency? Or do we try to achieve a more reliable communication, for instance? Depending on these goals, we may choose different scheduling mechanisms. One mechanism to consider in the scheduler is also if it's always useful to use a path. So you may have a work-conserving scheduler, which means that a work-conserving scheduler will always use a path when available. But sometimes it may actually be better to not use an available path and instead wait for some of the other paths that may be currently occupied to become available. So there are multiple choices that we have to make here in our scheduling decision. If we next consider reliable transfer, the issues involved here is first how to identify the data segments that we send over our multipath communication. And here we have to consider how to organize the sequence number space. Do we have a single sequence number space only at the multipath protocol level, or do we have sequence numbers also for each of the individual subflows? And here the decisions may be different in different protocols, and here is also one aspect where deployability becomes very important. So for instance, in multipath TCP, we have the regular sequence numbers at the TCP level, and we have another sequence number space at the MPTCP level, and this is needed in order to be able to deploy the solutions. For reliability, we also have to consider the retransmission strategy. When a packet is lost, do we retransmit it on the same subflow where it was originally sent, or do we also retransmit it on another path? So this is something that is also needs to be considered when creating a reliable transfer. Finally, let us consider the congestion control. So all transport protocols needs to have a proper congestion control in order to not overwhelm other flows on the internet and to make sure that you don't take an unfair share of the resources. So the congestion control has to determine how much data we are allowed to send into the network. And when we have multiple paths, we can now do this in different ways. So do we consider each path individually, or do we here need to treat the paths as a common resource? And if we have paths in the network where multiple flows may come and share some network segments, because even if we have multiple paths, they may not be disjoint, then we may need to consider that we have congestion control that couples the different flows for the communication, so that you cannot get an unfair share of resources just by having a lot of different flows in your multipath protocol. So to summarize, this lecture has introduced some of the key concepts that you have to consider when designing a multipath transport protocols. And in addition to the typical things you have to consider when designing any transport protocol, a multipath transport protocol must carefully consider all available paths in its design decisions. And the key issues involved that we have discussed is first the path management. How do we manage our connections and the multiple paths available in our connection, both to set up the paths and to decide if they should all be used for communication or not. Once we have the paths available, we have to consider how to schedule packets over those paths. This is the task of the packet scheduler, and we can have different goals here that will then determine what choices we make. In order to provide a reliable transfer, we have to ensure how we map the sequence space for communication, and we also have to consider how to retransmit lost data over the same path as the original transmission, or perhaps over another path. And we also have to ensure that we have a proper congestion control for our multipath transport. And here we have to make sure that we also don't take up an unfair share of the resources by communicating over multiple paths. And in our coming lectures, we will look in more detail on each of these core mechanisms.